So our fourth panel will dive into one of the most exciting and fast developing areas, digitalization and artificial intelligence in the energy system. Panelists will discuss strategies for building AI foundation models for power grid management and explore how TSOs and DSOs can share data for training, testing, and validating these models. So please welcome the speakers of our fourth panel. Marina Fernández-Campoamor, Head of Data and AI in Energy Networks at E.ON Digital Technology. Mečislovas Kaulakis, Innovation Expert at Litgrid, Lithuania's electricity transmission system operator. Gjalt Loots, Senior Program Manager at TNO, the Netherlands Organization for Applied Scientific Research. Miloš Nagy, Director of Asset Management at Západoslovenská distribučná, the largest electricity distributor in Slovakia. Ivan Pavičić from Department for Market Integration and Business Intelligence at Croatian Transmission System Operator. And Dimitar Zarchev, Director of National Dispatching Center at ESO Bulgaria. A warm welcome once again. And our panel will be led by Stavros Stamatoukos from the European Commission. With his policy expertise and focus on digitalization, he brings a unique perspective on how Europe can harness AI for a smarter, more efficient grid. I guess everybody is ready. Please go ahead. You have 40 minutes.
Thanks a lot. Good afternoon, everyone. Just to frame the discussion a bit, if you will bear with me 2 or 3 minutes, we will discuss AI. And I share all of your concerns here today. Probably it's not a priority for many of you that you have to build your substations and your power lines and manage the grids. But we should not disregard that it's here to stay. It's a global race for the development of the foundation models of the future. The models that will run will form the backbone of our grids in the next 5 or 10 years, or maybe more. So maybe it's too early, but we have to think ahead and see how we in Europe can play a role in this revolution. In other sectors, we have lost the train to other countries outside Europe. But this is an area that we are really having a competitive advantage. We have excellent energy and technology companies. We have the culture of cooperation. And we can lead in this race, not follow. So this is maybe an early discussion, but the European Commission is preparing a strategy how to embrace AI in the energy sector. And we would like to hear from you what are the bottlenecks and what is needed to accelerate this process. We are aware of many individual initiatives within companies, but it's not the same across Europe. And we work under the assumption that if we work together in a collaborative effort, we can accelerate this process. So this panel here today will discuss how we can build this collaboration. I can hear your concerns that maybe what we've been doing so far was not efficient enough with ongoing regulation or funding programs that we've been operating in Europe. And we might need to do it differently this time, to be fast, to be agile, and to be competitive in the global market. So any criticism is more than welcome that will help us shape this strategy. And with that, I will start with Dimitar, next to me. You're director of a dispatching center, and we were discussing the other day that you're running day-to-day operations to the limit. Is there a space for AI in this pace of your work? And what are the conditions that would allow this innovation? What type of tools and skills do you need to transition to AI?
Thank you very much, Stavros. Quite an interesting topic. And thank you for the invitation. So yeah, that's right. I'm running day-to-day operations in the TSO of Bulgaria. So just in brief numbers, we are operating more than 15,000 kilometers of high voltage overhead lines. In total, more than 400 substations, 300 of them are ours. Annual consumption of 37 terawatt hours in gross, peak load of around 7 gigawatts, and absolute minimum load of around 2.4 gigawatts. So you can imagine these figures, they show that we have to be very precise when we operate the system in order to provide what? Electricity to everybody. This is our main goal. In order to do that, you just made me in the lunch break think about the past. We are just obeying one simple equation I was taught of back in the days, 30 years ago, sorry to say that, at the university, and a guy there, a very old teacher, maybe my age at this point of time, he told me that the production should be equal to the consumption plus losses in the grid. And it was simple as that. So what is produced, it needs to be consumed, and it needs to be transferred, to be distributed, and so on and so on. In order to keep this balance, 20 years ago, even 20 years ago, we had sophisticated tools. We were vertically integrated companies. We were fully independent according to the primary resources, to the generation size, to the transmission, and to the distribution. Then everything changed, and it changed for better, I would say, because this is incentivized this unbundling that happened maybe 15 years ago. It incentivized actually the penetration of the renewables, different relations between all the players in the energy sector, new technologies, something that is really, even the people at the moment can feel it. 20 years ago, I was going to Thessaloniki with my diesel, speaking on my Nokia 3310, I think. And now I'm driving there with electric vehicle, using medias on my iPhone, and so on and so on. What happened? What happened is that actually from these conventional units, we passed to lots of renewables. Renewables are really producing most of the energy at the moment, at least on the Balkan Peninsula. And we have to maintain the same excellence during our operations. How do we do that? If we had 30 sites that we needed to observe 20 years ago, now we have hundreds of sites that we need to observe, hundreds of calculations we need to do, and hundreds of possible scenarios that we need to choose from in order to perform our day-to-day business. In the morning, I heard about DORs. Okay, we optimized active power flows, and then every split that was discussed from the morning, it was starting with the announcement of voltage co-ops. So active power is not enough to be controlled anymore. We need to control also the reactive power. We have new players, new set of services that are not only frequency-based services, but non-frequency-based services. We have this grid forming. I have heard a very nice question. Grid forming inverters, why don't we use it? And then next question, okay, synchronous compensators, why don't we use it? Then all of this goes to one dispatching center, and all of this goes to a guys, 2 or 3 guys that needs to take the decisions these decisions must be on time and must be absolutely correct in order not to suffer partial blackout, total blackout, system split, whatever you can think of, name it. How do we do it? We digitalize. And there was a question on your site, what is digitalization? Digitalization is where you have the data, you have enough data, and you can process it in order to make the right decision at the right time. For this, we need, of course, a lot of automation, we need a lot of telecommunications, and we need observability. And this observability must not be after the event in the next 15 minutes or 30 minutes. It needs to be achieved now, because as I told you in the beginning, actually what is produced, this is consumed, and this is the fact. In order to do that, we really need to deploy these networks and these automation systems that we need in order to achieve full observability of our networks. And I'm not talking about transmission system networks, because yeah, I was telling you that from 15,000 kilometers of high voltage lines, we have something like 9,500 kilometers of fiber optics. We have these digital substations, we have remote control rooms. All of this is already in place in the transmission system operators. Now we are talking about seeing the individual consumers in the distribution, on the distribution side. We really need to see what is happening there. They need to start playing as the big consumers are playing on the transmission side, and then really then we will achieve this automation, this digitalization that we need in order to foster our primary goal, you know, the Green Deal, the Fit for 55, and so on and so on. In order to do that, as a project, of course, because finally we are talking about projects, we started as a TSO, a common project with the DSOs on our territory, of course, to provide a common secure network, telecommunication network that will really go to the individual secondary substations of the DSOs and will enable all this data to be provided from all the points and from all the individual consumers to a central hub where we can process it, we can operate it, we can use it for secure system operation, but in the meantime, it will be used in order to be provided to the traders and these traders to make the best use of it during its market operation, because finally the final goal is all these really individual users to be active participants on the balancing market, which will incentivize actually this deep decarbonization that we are talking about, and also for sure will lower very much the system costs that are incentivized at the moment from ancillary services, from balancing, and so on and so on. So what is my main message actually here, and what I am hoping to provide as idea is that when the DSOs start to act like a TSO by means of automation and by means of deployment of all these means that we need actually to continue our decarbonization. At this point of time, really the dispatchers in our control room will need this passive artificial intelligence that will have to be there in place to be able to process all these huge amounts of data, the big data, you know, idea, just to process this and to give us possible scenarios for any of our online situations that we have to face. So thank you.
Thanks a lot. So passive artificial intelligence is what I keep from all this interesting approach. So Ivan, I come to you. I think you work in development of actual solutions, right? And I would like to give us an idea of what are these concrete, you know, the abstract AI models that we say. Can you give us some concrete use cases and problems that they solve, you know, in simple words?
Thank you for the question. So just to recap of the our experience with AI. We are using AI almost 10 years when the first model occurred. First model was for load prediction. The idea behind that, it was more accurate. That was the only idea why we use it firstly. And after that, we made some other adjustment to existing model, and we also developed new tools for forecasting wind production, losses, procurement, photovoltaic. Right now we are in that process, and some kind of prediction of the market prices only for the ahead time period. So our experience from implementing AI is quite straightforward because it was simpler. For us, it was a little bit easier to understand how to achieve the goal with the same amount of data. So we didn't need to make all these analyses like physical models that you need to develop. And the idea that we do not have that software development in the case of some existing tools. So from our perspective, until today, we have a positive experience with the AI, but this year we experienced some challenges. I will say that, because all this data was trained on the historical achievements, historical measurement and so on. But today, this year, we experienced some new not scenario, but new data that was not real-time data that was not before in our system, and the existing model cannot handle that. So that's the one of the reason that we need for the next upgrade or retraining the existing model. We need another set of data that already have that, let's say, an anomaly in itself. That's the first thing. And the other thing that these all AI models that we developed didn't have any background in the existing regulatory acts. So as I understand, from this year there is a EU AI Act. There will be some kind of guidelines how to monitor, how to make some security analysis about your influence on business decision, networking, security, and so on. And there is also might be some kind of possibility to have make some reports of monitoring your AI tools. So for us, there is some kind of uncertainties. Who will do that? Who is responsible for that? And who will revise that kind of document? So in the future, we expect some guidelines on the European NCE level. That's the first thing. And the other thing is to have some kind of KPI index to see what other countries are doing and what's their benchmark in some of the category that we already using AI, and to make, let's say, step forward if we are not on the same level.
Thanks a lot. Very interesting, and thanks for making this reference to the EU AI Act. It's coming into effect this summer next year. The high-risk use cases and critical infrastructure is among those. And indeed, we aim to issue a guidance on what will qualify as high-risk use case. And for this, what are the individual steps that companies have to undertake, like documentation, risk assessment, transparency of the models, etc. And this is a good link to the next question. I will come to you, Mečislovas. Probably I will ask you to play the bad guy tell us about the risks of this new technology. So given that energy systems our grids are critical energy infrastructure, what are the safeguards that should be in place, and what are the potential risks in developing AI models?
Thank you for putting me a bad guy place, dressed in white and light. Okay. I'll sum up probably view of a lot of TSOs is security first. When implementing any new technology, especially one that can work with your data at a pace you cannot catch. Okay. Starting from beginning, in working in innovations, I receive a lot. Once, twice a week, I receive an email from some industry company asking to speak with them about a new AI tool that they offer. Okay, they range from asset management, operations, digital twins, substation automation, digitalization tools, controlling your system HVAC, buildings HVAC system with AI. Don't know why I need those, but they're mostly harmless. Yeah, they work in their own bubble. They do the work. Those little AI systems, but once you start going into operational, working with operational data, making decisions that affect, how the energy flows go, what relay settings get set, who is to curtail based on congestion in one part or another of the grid. Then you come into a kind of a wall, and you have to step back and think. We even stopped AI pilots halfway last year, which was very helpful, potentially, to help us crunch on purchasing data, help us input, understand the purchasing requirements, put them into a online system that everyone uses. It's usually you would have saved thousands of hours. I think about 8,000 hours estimated a year of purchasing department, but was stopped dead in its tracks because we realized we don't know how to work with AI tools. Why? Because we did a kind of a short questionnaire of the company. How do you use open ChatGPT? Everyone was like, okay, so we use it to scan in documents and provide input, summarize. And not always do people think of what kind of information they share with the AI models. Of course, it's compartmentalized. It's there just for you. It's not going to publish that data, but still, it's just one example. So, from Litgrid perspective, we are lacking internal regulation, lacking competences, and general education of the workforce of how to safely, securely use AI tools. There was this EU regulation 1689 of last year that, among other things, describes rules for safe AI use, and it's got also has fines in there which are quite hefty for improper AI use. It's capped at 35 million. We as a critical infrastructure owner, we fall under that, so it's a big risk, and we have that risk identified. We have a whole plan set up for a year ahead of putting those regulations in place and educating the workforce. We have loads of, from another perspective, we have loads of data sitting in our databases that wants to be used, needs to be used. We have DLR systems, we have digital acoustic sensing, which provides low gigabytes of data a day. We have the whole grid scanned with LiDAR. We have autonomous drones running around, flying around. We have WAMs and other systems that are really useful tools, but we cannot use them fully. We need AI models that would crunch data down to usable format, and we'll have digital substations in the future, and those mean, you know, there's a big AI model controlling the whole substations, the whole network for you. And I think, in my opinion, end of the day, AI, as somebody before mentioned, technology is there to be useful for you, and there should always, AI should just provide you with options of what to do, and should always be human at the end making decisions, especially for critical systems. So yeah, we can discuss a lot about this, but essentially security first, and we need to think just in the name of progress. We should not head there unprepared.
Great, thanks a lot. Human in the loop, that's very important, and it's part of the AI Act, one of the requirements. But you mentioned data, and this links very well to the next question. It's for Miloš. You collect millions of data points from your assets, right? How do you give value to this data? And maybe a second question, if another DSO, for example, Ivan or someone else, can give value to this data and share the output with you, would you be willing to share this data with them?
Thank you, Stavros, for this question. As you mentioned, our distribution company deals on a daily basis with millions of data about our grid, about our customers. Nowadays, it's not the question if we have the data. Even thankful for the PCI projects, we have digital primary substation. We have digital secondary substation. We have plenty of points with measurement, with the fault identification in the medium voltage grid on the auto recloser or disconnectors directly on the medium voltage grid. We have several hundreds of substations from medium voltage to low voltage with measurement, with signalization of the state of many parameters. We have thousands of substations with the smart measurement. We have several hundreds smart meters in the grid. We have a lot of data about our grid. I start with some very short story. Maybe 1.5 years ago, I start following the rabbit. The rabbit has the name AI. And maybe 2 or 3 months ago, I really fall into the rabbit hole. And now I'm just like Alice in the Wonderland. And till now, I'm not met the heart queen. Why I told the story? During the last maybe half a year, I really work intensively with the many type of large language models like AI, Gemini, ChatGPTs, and so on. We could name a lot about it. And what I learned on that journey is that we could talking about the data, talking about the process, talking about our expectation of the future, but we have to have the right question for these models. Are we sure what we're expecting from the data? And who asking this question? This is the crucial way or crucial things what we have to know on the journey. We are able to provide data to whole market, but for what purpose? The data cost money in these days. It's not for free, even for the distribution companies, even for the TSO companies. Your question, if we are able to find some additional value from this data. Yes, we are. We are able to communicate digital with our customers when they are asking for the connection. We are able very fast response to our customers when they have a problem with the electricity. Yes, we are able to communicate very openly with our customers about the faults in the low voltage grid directly. We are able to answer to our customers, no, the outage is only in your house, not in the grid. It's the today reality. And when we are talking about the sharing the data with the rest of the market, yes, we're sharing the data with the rest of the market. All smart meters provide the data into the data center, and each subject on the market what has right to get this information, they had it. The better question is for what we are aiming in the future with the data. As the European Union itself, because we are like a sleeping beauty nowadays. Unfortunately, it's true. Because the whole world developing their own large language models. We are just start discussion about the AI. It's not about the tools, not about the softwares, it's about the people. We have to start immediately working without people, without educational system, with our universities, and with our young generation. Then when I can summarize your question, if we are able to sharing the data, yes, we are able to sharing the data to the market. If we have some additional value, yeah, we have. Yes, we have. That's a very short story from my side. Thank you.
Thanks a lot. Very telling, the story and the narrative. Thanks a lot, Miloš. Marina, I come to you. You work across different DSOs, and you're in a tough position to collect data sets from all those DSOs into a common infrastructure. Will you tell us a bit about quality of data, not quantity, and interoperability, and how you bring all those together?
Yeah, indeed. Thank you. I mean, you know, when we are talking about the importance of data and how it's so important, the amount of data that we are collecting, but how are we connecting? And to me, I want to take a step back and say that it needs to start from the different organizations. Is digitalization and data management at the strategy? And then that means that you are going to invest time and resources. And here it comes from your point where you're saying, like, we don't have the knowledge, or we might not have the professionals. And I know that data engineers do not grow on trees, or like electrical engineers neither, but still investing on having some data professionals at your team is fundamental. Either if you want to build your models yourself, you want to build your AI models yourself, or if you want to buy them, you need someone that is able to establish, okay, can I challenge my vendor? Can I challenge my provider? Is really what I'm building or what this person is building makes sense? And then on top of this, I would say that we are very much used in the sector to have this waterfall structure of running projects. I think we need to bring an environment of collaboration. You were asking, like, who needs to build the requirements on security, on volume, like what do we need this data for? It's like both ways. I think the business has to establish this. What is the answer that I want, or the questions that I'm asking myself? And then the data engineers need to come along and challenge them. Bringing, for example, data engineers from the industries help a lot. And we need to be very bold at simplification. You cannot imagine how many times I get requests on, yeah, this data field is so fundamental, we need to have it, we need to implement it, and then you check and it's not filled. It's not used, and you're just making your platform not efficient, slower, and costly. Actually, I think it was Adam Toth from E.ON Hungary was mentioning how he was surprised about the cost of the infrastructure, and this needs to be evaluated by a data professional. And then when you have all of this, which is not easy because you said it yourself that the technology is not the problem. It's a change management issue. Then it's a matter of, okay, how are we going to design this data platform? And of course, I would recommend you to go as much as possible in the standards. You don't need to reinvent the wheel. Use industry-wide technologies also for the talent problem. If you're going to go into a very niche technology, then it's going to be very, very hard to find these professionals that can maintain ultimately this platform. So overall, I think to have this data interoperability, you need to take a step back and then have the commitment from the organization. And I'm not only talking about the DSOs. I would say regulators also need to invest on this as well. Have the commitment, invest in this talent, in the co-development, and then of course push as much as possible on industry-wide or industry-adopted technologies. So that will be more or less my take on this.
Thanks a lot, Marina. Gjalt, I'm coming to you. You're part of one of the innovative Horizon Europe projects, HOT, that you develop the innovative technologies of tomorrow. If you could give us a sneak peek of what's coming from the innovation side that could be in the next 2 or 3 years deployed in the market?
Sure, thank you, Stavros. Also, thank you for having me, for inviting me to Ljubljana, although the weather today is not so perfect, but still it's a pleasure to be here. Please allow me to first give a little bit of context. I'm not running like Dimitar a TSO network, but I'm from the Netherlands, which is roughly 2 times the size of Slovenia. I recognize that many of you are from Central Europe, so I give a little bit of an introduction. We have 8 times more people than live in Slovenia, so easily calculated. The population density is about 4 times as high. In the country, we have 99% of the grid in a congested area. So almost the full country, there is a shortage of energy, so to say. To give you an idea what it comes down to, if you build a new house in the Netherlands, the average waiting time for you to just get a normal grid connection, a power connection, is 1.5 years. There are areas in the Netherlands, if you have a company, and you want just a regular connection that applies to a company, which is a bit bigger than a household, but I mean, it's not the biggest client to the grid. There are areas where you have to wait for 10 years. Which I think illustrates the severity of the situation in which we are. So I would say in the Netherlands there is a very big demand for more capacity on both transport and also on distribution level. So the grid needs to be expanded rapidly. Also the amount of electric vehicles is rapidly growing. We are also moving away from gas-based heating for houses and buildings. We are moving to HVAC systems, so heating, ventilation, air conditioning, all electricity-based. We do have a lot of PV production, but of course the PV production takes place in summer, and we need the power for heating in winter. So there's a big, I think, a very universal, illogical situation here where you have the production and the consumption of the power not to be in sync. So in order to address the whole situation, there's a big hope not only to physically expand the grid, more cables, transformers, power stations, etc., but also to do things smart, because digital innovations typically may take place at a higher pace than having a physical infrastructure being brought into operation. It takes years and years, assuming you even have the people. We have a big shortage of people. If you're a good engineer, I think the story so far illustrates we have a lot of work. There's a lot of opportunities in the Netherlands to work on this area. So in order to move, in addition from physically expanding the grid, moving to digital systems, of course, there is very big hope, and there's a lot of promise in making grids smart, and by making use of AI, as of the previous speakers in the panel also indicated, AI is anywhere from your watch and your phone to many things in the house these days. Your kids may use AI to make exercises at school very easy to do, etc., etc. So AI is everywhere. On board levels, there is a general conception that AI may be the big solution that the electricity grid also needs in order to address all the challenges which are coming at us. But first before being able to successfully apply AI and taking security and other aspects into consideration that we've discussed in this panel, AI needs data. It needs to be trained before it can be deployed. And I think it's already a challenge within one organization to have access to the information, to have quality information, to have availability and the right types of data points, let alone between organizations or even across the whole electricity grid and electricity system as a whole. So that's why we are in the Hedge IoT, which is a Horizon Europe innovation action funded by the European Commission, developing solutions that allow for the exchange of data in an organized way. We call it through data spaces, where, for example, the ownership, reliability, all kinds of security aspects are all taken into account. It's not that you just open the door and say, if you want my data, walk in, because if you open the door for a cooperating party, you're also opening the door to a hacker, which of course in terms of having a critical infrastructure is not a very acceptable risk to take. And once, of course, data exchange is in an organized way catered for, parties can also multilaterally exchange information for any kinds of application. We're building in the project a number of applications that demonstrates on scale in different countries on how that works and what the benefits are. And then yet another layer that we are addressing in the project is not only the exchange of information for AI, but also we are tackling the issue of interoperability. And that may be a new concept, so I'll just explain it on a very high level. Interoperability is the capacity of systems to work together. So to not only talk and have exchange of information, but also to work together. Where we nowadays see in modern society that if there are EV chargers that can also feed energy into the grid, if there are HVAC systems that have a demand response capability, the devices do not only need to be plugged into the power, to the outlet, so to say, but having a connection to the internet and allowing them to exchange information and to change their behavior based on the dynamics of an electricity grid brings yet another layer, I think, of digital solutions that are needed here. So in a nutshell, to summarize, AI needs data. If you want to exchange data, you better do it in a very organized way in order to get any cooperation going across the entire electricity system. And once you're able to make use of these applications, we also develop open source solutions that anyone may use for interoperability. Again, giving a solution for systems to cooperate, to work together.
Thanks a lot, Gjalt. So I had another round of questions, but I think in the interest of time, we will not take it, but I will give it open to the public, and I will ask my colleagues at CINEA and LS to forward to the participants. I see a question there.
Okay, happy to see that we have a question. Here you go.
Hi, so I'm Frédéric Simon from Carbon Pulse. I was interested to hear if, by experience of any of the panelists, the AI is being used for meeting climate objectives or decarbonization objectives, whether it's helping in that sense or not.
Okay. For meeting planning objectives and for really extracting, especially during big meetings, but this is administrative actually, what we are using AI at the moment in our company, and it has really huge results. But in operations, actually what we use and is close to AI, I would say, are the planning and network analysis tools that we are using at the moment. For example, we are building, of course, dynamic topology of our networks. We have these rolling forecasts and rolling schedules and generation profiles of all the assets that are on our territory. It's done every 5 minutes. As a consequence of this, of course, at the moment we have countermeasures in case of violation of security criteria or big imbalances and so on, which are assisting to our dispatchers, but I don't take this as real AI at the moment, because these are tools that we are using maybe more than 20 years already. They were deployed first as a really sophisticated tool, but it was somewhere around 2005 up to 2008. And they are based, of course, on these models. They are based, we were discussing just in the lunch break with my colleagues, based on this simplex method and another methods for linear regression, and also on the theory of the game, on statistics. But I don't see it at the moment as real AI. I think that these models need to be improved, and I'll just say that I had this conversation with a friend of mine maybe several days ago. He was using ChatGPT for the first time, and his impression was, it's out of my mind. It's like talking to a really clever guy who gives me really alternative solutions to what I think, to my models. So this is maybe the way we should aim, and the ending point we should go. Of course, cybersecurity, of course, own infrastructure and so on, everything is in place. But really we should put the technology models that can be processed from this new type of AI.
Thanks a lot, Dimitar. So I think we need to close, right? If I may, just 1 minute. Again, we are trying to put our minds around how to accelerate the transition to AI, the use of AI in the energy system, but keeping at the same time all risks at stake. So we are running a public consultation as we speak. It will be open for another month and a half. And I invite all of you to bring forward your ideas. I see that we are in a good place. I see individual efforts in different companies, but the objectives are to bring them all together and accelerate the pace. As I said, the race is global, and we risk of losing the race again. So the objective is to put our minds together and try to develop the tools that will run our systems, giving us sovereignty and independence over the next years. Thanks a lot.
Perfect. Thank you. Thank you, Stavros. It's quite an important homework that you're giving to us, right? Yeah, we'll do our best. Thanks a lot.